Today's focus will be more on the mobile-to-mobile voice quality testing as well as the data testing. So nowadays there is a more focus given on the voice quality, especially with regard to the different networks available like 3G, 4G. It's a real challenge for every service providers to provide the best voice quality for their network. And in order to test the voice quality, they need the tools like our VQT and Vquad. So in today's webinar, we will be focusing more on the aspects of how you can do these real-time voice quality measurements using various tools available with GL. And today's webinar will be presented by my colleague Girish.
Hi all, this is Girish from GL, and today I'll be providing a presentation on voice and data quality testing solutions for wireless networks as well as wired networks. In today's world, as you know, voice quality testing is one of the major concerns in the telecom industry, and most of the vendors, service providers will always be looking for this voice quality testing. Our Vquad with voice quality VQT software provides a complete solution to test voice quality over different networks. As you can see, this is a basic overall structure of our Vquad, supported over different networks. Like it may be a wireless network where we use any kind of a wireless network like Bluetooth, 3G, 4G, LTE. It may be a PSTN network. It's a 2-wire RJ11 connection for any analog phone. It may be a IP network like Voice over Internet Protocol, which supports SIP. It may be a T1E1 network, TDM network, where it supports like CAS, ISDN, PRI. So as I was describing, Vquad can be used to simulate different devices over different networks, place calls using different mobile devices or analog devices or VoIP devices, make calls between different networks using different devices. Then you can perform send and record voice files. You can perform different traffic actions like send tones, send digits, DTMF or MF digits. Then all these results you can perform one-way delay measurements, round trip delay measurements. You can perform data testing. Even data testing is supported, like performing different data tests like TCP, HTTP, UDP, Voice over Internet Protocol. So you can perform different data testing. You can perform different echo measurements. And all these results can be sent to our central database. As you can see in this diagram, central database. So this central database is a web-based application where you can query all your results sent from Vquad, VQT, other records, and monitor the results using this database. You can query based on different filters. You can query the results based on different timestamps or call device phone IDs, call IDs. You can monitor all the voice quality statistics. So the different cases. These are the system highlights of Vquad. It basically provides a single box solution with following interfaces. Any communication device can be connected to our Vquad software, paired with our Vquad software like mobile phones, smartphones, military, Bluetooth, WiMAX or Wi-Fi. Any communication device can be connected to our Vquad. It supports 2-wire ports, like you can connect to PSTN, you can connect to ATA, analog telephony adapter. You can connect to media gateway to our ports using the GL's dual UTA. We support a 4-wire analog, like you can connect directly to any telephone or any digital wipe hardware phone. Any handset device you can connect to test for a 4-wire analog. We also support voice or internet protocol, and it acts as a SIP call agent. Instance, you can use this Vquad to test any soft phone or to perform any registration using a registrar server, or to perform a proxy. If you want to place a call over a proxies, you can use it as a soft phone and SIP call agent over different proxy servers. In TDM, you will be using, it supports CASP as well as ISDN protocols using GL's USB T1E1 analyzer.
Yeah, Rob want to comment on this.
Hi everybody, this is Rob.
Okay.
Just wanted to comment on the slide a little bit. With the Vquad solution, we can connect to virtually any interface. We can connect to any wireless device, a phone, a tablet with voice, sort of like what I'm doing here, a radio, a wireless phone, not a mobile phone, but just a wireless phone handset, pretty much anything. And then when it gets into the radios, we can go into military, into government, anything that has a radio. Anybody that has a radio, we've connected to, for instance, the radios in the London Underground, and we're testing with Thales radios there. We're testing throughout the U.S. with the military and the government, the Mass Transit Authority, all these different types of devices. Also, the 4-wire interface that Girish mentioned, that's very important, because then we could be a headset to any device under test. Some examples are, we can be a headset to a mobile phone. That's the most common example. We can also be a headset to a soft phone on a PC. So anything that has a mic speaker, we can plug in. We can also plug into a HATS system, head and torso. We've done that before, where we're the ones that are pushing the audio or receiving the audio into the HATS. So we sell to the customers that require HATS but need the audio as well. We've even connected to a hospital bed. One of the main manufacturers of hospital beds in the U.S., Hillrom, they needed to test the communications from the hospital bed to the nurse's station, and we provided that methodology that technology, I should say, to test from the hospital bed to the nurse's station. We gave there was Vquad on both ends, and they performed voice quality. So pretty much anything that requires audio testing, voice quality testing from one side to the other, and the two sides can be completely different. We're fully independent, so we're phone independent or independent of what from side 1 to side 2. We're fully independent, and we're independent of the network itself. So everybody asks, well, can you do 3G? Can you do LTE? Can you do voice over LTE? Yes, we can do everything. We don't care. Okay, we don't care what your network is, because we're the endpoint. We're the customer experience. We're sitting at the device. So we don't care what the network is. We don't care what the device is. We just connect to it, and then we generate the voice. That's what makes us a lot different than everybody else. Okay, so that's all I wanted to say. Sorry, Girish, you can continue.
Yes, yeah. Thanks for the input. This is our dual universal telephony adapter we were talking about. It's a USB device which can be connected to a PC via USB port. Basically, it supports different kinds of interfaces, as you can see here. It basically supports analog FXO interface, which is connected by RJ11 port. It supports balanced audio headset ports. You can connect to any 3.5 mm audio jacks if you are testing any smartphone. If you are trying to test a 4-wire, you can connect the audio balanced cables. If you are trying to test any handset, for it may be an IP phone or it may be an analog phone, you need to connect it to the headset base. We do have a GPS port in our J45 GPS port, wherein which we connect the GPS receiver to this port. So basically this GPS receiver will be used for mapping GPS results at different locations. This GPS receiver communicates via satellite, and based on that, whenever when you perform send and record voice files, so with the recorded voice file, this will be mapped. Or when you perform any kind of a data testing, it will be used to perform, it will give you the results at that particular location. So this will help in determining the quality of the network or the data test results, at what particular area, what is our voice quality, or at what particular area, what are the different network parameters. Then for wireless,
Girish?
Yeah.
The GPS is also used for timing.
Yeah.
Okay, very accurate timing for one-way delay. So we can do, if you're trying to do one-way delay between two different locations, this will give you accurate timing. It's needed. GPS is needed at both ends. Or if you're doing echo measurements, because we have an echo measurement utility that Vquad can use, and you need GPS at both ends as well. So this not only gives the GPS coordinates for any test, any results, not just voice quality, but any result, whether call failure, call drop, because customers want errors or path confirmation or voice quality or what have you. This gives the GPS coordinates, but it also gives the accurate timing. And the reason there's an in and an out is because you can plug the GPS receiver to the in and then take a cable from the out and put that on another system. Okay, so if you have two dual UTAs co-located in the same room, you don't need GPS on both. You just need GPS on one, and then you can take a cable and move it over to the other one from out to in, and now GPS is on the second unit. So we took a lot in consideration when we implemented that. So, sorry, Girish.
Yeah, thanks. And as told before, like PTT push to talk, like Rob said, we support PTT devices, any military radios, any radio hardware phone we can support, and we can use to connect it to a Vquad and perform different traffic operations. Any questions?
Okay, so I just wanted to comment. Does everybody understand the versatility of this dual UTA? That's very important. This has all these different interfaces on one box. It's very portable. It connects to the PC via USB. It's very small, like the size of a small book. It has two sides to it. So everything on side one is repeated on side two. So with this little box in your PC, and Girish will get into another platform in a minute, with this little box and a PC, you have all these interfaces at your hand and ways to do testing that are very compact, very simple, and very portable. Throw it in a car, put it at a lab site, put it in a building or a cell tower, whatever you need. That's what we try to get at with this type of solution. Very portable. No external power required. Gets all its power from the USB. Okay.
Can I ask one question?
Yeah, sure.
Okay, this is Mark with the Coma speaking. I have a question in regard to the Bluetooth. So when I visited the GL communication last year, I heard that in order to measure the voice quality of the voice over LTE with using the QA, the Bluetooth feature should be updated because in order to have the wideband voice range. Yeah? So at this moment, your UTA is supporting the updated Bluetooth or not yet?
Hi, Mac. Yes, it does. There's a new version of the dual UTA. It's just an enhancement. And it does include a wideband Bluetooth card. It's available now. We can't update your system in the field because we also have to make a slight change to the dual UTA itself. But it does have wideband capability, and the software was updated to support that. So, and we did this specifically for voice over LTE. We're testing voice over LTE here in this country for a couple of providers. So, absolutely, yes, that's available now, and and we can support it.
Yeah, that's great. Thank you very much.
All right, Beck.
Yeah, and yeah, these Bluetooth chips are all basically designed by using the industry standard CSR chips, and we support hands-free profile. So, which is again, which is almost available in all the today's modern phones as well as earlier phones. So, any phones which support hands-free profile, we can pair with the Vquad without any issues. As described, these are the features as we just basically described, like on what all devices we can connect. Then the two sides of interfaces are completely independent of each other for end-to-end testing. We are always at the endpoints. As Rob said, we are at the user experience. We support voice quality testing, and we support fax generation, fax or 2-wire as well as 4-wire. And all industry standard modems currently are supported, like V29, V34. The latest V34 modem standard is supported. We support data testing and echo measurements. Like said earlier, we support RTD, one-way delay and round-trip delay, push-to-talk, and GPS support. These are some of the system highlights. Like it can control up to 8 simultaneous devices. Multiple dual UTAs can be connected to single Vquad system. Currently, to one Vquad, we can connect 2 dual UTAs, and we are coming up with increasing the number of dual UTAs to 4 somewhere later in this year. So one local Vquad can control remote Vquad systems to expand testing for an entire network. You can send different DTMF MF digits, you can transmit and detect tones, you can perform drive testing with GPS mapping as described earlier. You can perform the ITS. ITS is used to test the VQT in remote and unreachable GPS signal places. For example, it's underground. Data testing is available for all mobile devices which support like iOS, Android and other platforms. We can also do PC-based Ethernet testing. For example, a PC Ethernet card connected to the PC, you can perform test different TCP, HTTP, UDP tests over that. This is our Vquad probe. Vquad probe is all in with a self-contained system. It comes as a system, whereas dual UTA is just a USB portable device. Whereas Vquad probe is all in self-contained system. It comes within as a single. It has come as a system. It basically consists of. It has got 4 USB ports. It has got 2 LAN ports where you can connect to Ethernet port, or you can connect for powering the phones. So it has got the similar interfaces as of dual UTA, like FXO analog, then headset. It has got GPS in and out. Headset base, Bluetooth. The advantage of this, the Vquad probe is it will be all in self-contained system, wherein which you can use the USB ports and you can use for powering the phones and perform the test.
Yeah, Girish, Chuck is asking, is there a CLI or the TCL interface available for the automation?
CLI, we have a CLI for both Vquad as well as VQT, CLI commands, using which you can perform automation. And regarding TCL, Rob, you're there?
Yeah, we have had customers use Tickle. They basically use our CLI within their Tickle. So that's the way we would support Tickle. It would all be through the CLI. And with the CLI, we can pretty much do anything on the Vquad. So the Vquad has full and complete remote through the CLI. Gears will get into how we can remote it through a web interface. One Vquad can remotely control another Vquad. So there's a lot of remote capabilities within the Vquad.
These are just highlights of supported features. Include portability and remote accessibility along with necessary PC hardware. It's supported operating systems of Windows 7 and Windows 8. It is controlled via Ethernet remote desktop with support for mouse, which has support for mouse and keyboard, and is of same length as the current dual UTA hardware, but as high as and twice as high, as well as 50% wider.
So the point of the Vquad probe, which is the all-in-one unit, the point of this unit is to leave it somewhere. Okay, so leave it in a lab, leave it completely unattended. We have these all over the world, and they're just boxes sitting in a room. It doesn't look like a laptop. It doesn't look like a computer, I should say. So nobody's going to touch it. Nobody knows what it is. That's great. And you don't put a screen on it. You don't put a mouse and keyboard on it usually. You just remote into it. Whether it's a CLI or a remote desktop or what have you. Some of these customers, they put on like log me in it, whatever. It's because it's a PC in there. We could throw VQT on the same box. We could put, because it's a PC, so we could put whatever you want in there. But again, the main thing about this, it's a box that can be left somewhere unattended, running, and nobody's going to touch it. And the other thing you can do is throw it in the car for drive testing. You don't have to have this big laptop and the second box. You just put this in the car. And what's cool about this too is the power interface. So it's a screw terminal. So we put that, we designed that specifically so the power is not going to be pulled out by accident. But what's also good is when you plug the power in, the unit automatically comes up, starts running, and in fact it can start, we can set it up so that it can start Vquad automatically, load a test, and run a test without you ever having even to log into it. So we have those capabilities within the software as well. It's a pretty portable and standalone box.
This is a block diagram of our central system, including all the Vquad probes. These Vquad probes, as well as the Vquad dual UTA, can be located anywhere in the world and can be paired to any of the devices or different networks. This block diagram shows a Vquad being deployed anywhere in the world and being connected to our different interfaces and different devices or different networks. And we can send all the results to our central system, which is our called as GL's web viewer, and you can customize all your reports based on different parameters, filters. You can perform all the voice quality testing, EMU testing, is echo measurement testing, voice quality testing. You can perform different data testing or different networks. Vquad can control remotely different mobile devices, and Vquad will be sitting anywhere in the world, and it can control through MDC, it can control the different tests and give the results to web viewer.
So this picture gives a full, complete solution. You got Vquads all over the world, or just in your location, or just one Vquad, doesn't matter, we don't care. You can have 100 Vquads, one Vquad, doesn't matter. It's connected to the Ethernet, the internet, or the network, or private network. All the results are going to a central database, Oracle database or an Access database. The analysis is done at the central database, so you put a VQT, a voice quality analyzer, at the central location. It'll perform all your voice qualities. You don't need voice quality analysis at each Vquad location. That saves a lot of money. Because every time you put a voice quality at a location, you need to pay the royalties for that algorithm. We only pay once at the central location. Then you have these web viewers, and basically the web viewer, you can bring it up from a PC, from a MacBook, from an iPhone, an Android, a tablet, anything, because we support all the different ways to go to the internet. Someone have a question?
The question is there anything we can't measure in the data domain?
Anything we cannot measure? Well, I think we need to go through anything the things we do measure. And Girish will get to that in a few minutes, where we'll get to the slides of data testing. So we will get into what things we do for data, like HTTP and FTP and TCP and so forth. So we'll get into that. We have some slides for that. But the main thing about this picture is everything, all the results, all the events, everything will go into a central database, and then you can access it through a web browser, remote control everything through the web browser. So it's a very complete solution.
There's some again highlights of like hundreds of Vquad nodes can be geographically distributed. Vquad command center can control multiple distributed Vquad nodes, and it can initiate voice collecting tasks for VQT analysis and echo measurements. It uses a file monitor application to transfer voice files automatically for voice quality software to do analysis. And all the Vquad and VQT results are automatically transferred to the central database via the TCP IP connection. If the connection also fails, the results will be saved to the local database until the connection is re-established. VQT web viewer will provide you an option to query all the results. You can export these results in all three different formats like PDF, text and Excel format. It also helps you to get the network status of particular Vquad node and also perform different remote operations using a network within the network from a web-based application. This is a slide which describes us wireless to wireless testing over different wireless networks like GSM, CDMA, VoLTE, voice over LTE network, a Wi-Fi, radio, 3G networks, a UMTS network. So this slide basically describes how we perform different tests using a wireless network via Bluetooth. We can place calls between two different mobile devices connected via Vquad, and those Vquads may be geographically separated. They can be anywhere, and once the call is established, we can send a voice file on one side and record the voice file on the other side, that is on the remote side. And these voice files can be given to VQT software. This voice quality software will compare the sent file with the recorded file and give you the MOS scores, which is in terms of the PESQ, Polka. So based on this, you can perform voice quality testing over any wireless network. VQT can be installed at either end and run concurrently with Vquad or subsequently on another PC that has access to the recorded files. This is another slide which shows you a wireless testing between a wireless network to a PSTN network. PSTN network, as you know, you can connect a FXO line to a dual UTA, which acts as a PSTN analog phone network, and to a wireless network using Bluetooth. Similarly, you can place calls between a PSTN network to a wireless network, and then you can perform different operations like round trip delay. You can perform one-way delay. You can perform once again send and record voice files, and perform send and receive voice files, and perform VQT analysis, which will give you the voice quality. This slide indicates the soft phone to soft phone testing, that is wipe to wipe testing. For example, we can test any kind of a soft phone, like it may be a Skype soft phone, it may be a Viber, it may be any kind of a soft phone. We can perform a voice quality testing using our Vquad. This slide describes different soft phone testings network within a wipe network, and sending the results to VQT, which will give you the voice quality analysis, and then you can send all these results to WebViewer, where you can query the results. Any questions for these 3 slides?
So I think the big thing about these, the main thing that we're trying to point out with these 3 slides, this is just 3 examples. As I mentioned earlier, we can be anything either side of a call. One side could be wireless, the other side could be 2-wire or 4-wire, soft phone, what have you. We don't really care because each side is independent, and we're generating a call from one side to the other, and then we're doing voice quality and delay measurements and signal to noise ratio and echo measurement and pretty much anything. So we're fully independent on both sides. That's the key here. So it just makes it very versatile. And any of these little boxes here where you see a laptop and a WTA, that can be replaced with the Vquad Probe, the single all-in-one unit. And the other thing that I wanted to mention is these pictures just depict one side to the other side. One person calling another person. We can also do conference calling. We've done a lot of testing for customers for conference calling, meaning that we're going to have 10 or 12 or what have you calls go into a conference, and then we can test voice quality among the different callers. So that's also available. We're not limited to one point to another point.
Rob, Naveen has a question here. He's asking when we measure PSTN to wireless connectivity, how do we know which network is causing the problem on the VQT?
Well, that's a good question, and sometimes it's hard to figure that out. But that's one of the things that we do is we do bi-directional testing. So we're going to test from wireless to, we're going to send the voice file from the wireless to the PSTN, and then from the PSTN back to the wireless. And that's going to give us a good idea of who may be causing the problem. It may not give us full disclosure, but it'll give us a good idea. At times, what you recommend, if there's an issue, we may want to move the equipment around, our test equipment, to narrow down even further where the issue might be. So this will give you a good idea that there is a problem. With the bidirectional testing, it may give you a better idea of where the problem is coming from. But a lot of times we may have to move the equipment around by isolating the mobile device or isolating the 2-wire device to find exactly where the problem might be.
This is a drive testing with Vquad, which we had talked about some time before, like using the GPS receiver connected to the dual UTA. We can perform different drive tests. It can be accomplished with one fixed node and one mobile or both ends mobile for more dynamic testing. For example, one Vquad node can be static and the other Vquad node it may be mobile. So based on that, the stationary end is served by an Vquad with analog option or a mobile end with a wireless phone. So once this setup is done, through GPS satellite, GPS communication with the satellite, so one mobile end Vquad and other static end Vquad, you can place the calls using different interface, and once the call is established, you will be sending voice files from side 1 to side 2 or bidirectional from side 2 to side 1, and this will map the GPS coordinates with the recorded files. So based on this, you will be, and this will be sent to a central database web viewer, wherein which you will be able to come to know at what particular point the voice quality is higher or at what point the voice quality is lower. And also, as stated, you can also come to know what are the status of the different call control events, when did the call drop, when did the call was successful. This is just a diagram of a Vquad GUI where it shows what all the kinds of interfaces that are supported, which we discussed earlier. Like it supports PTT, it supports Bluetooth, it supports mobile. For mobile interface, you can use 3.5 mm audio jacks for smartphones, and for old generation phones, you can use 2.5 mm audio jacks. We support FXO. We support handset to test any analog phone or any IP phone. This is basically a Vquad auto configuration feature, which is just a simplified way for the user to build his own user-defined scripts. It's a simple configuration for any new user of Vquad to start with. And also we have automated call control and traffic scripting, wherein which you will be running different call control scripts, for example in some complex scenarios, and this can be used to configure the scripts and run automatically. Entire thing can be automated, like placing calls, sending traffic, performing one-way delay measurements, SNR measurements, everything can be automated. Now we will move to voice quality testing software. This voice quality testing software supports ITU standards, the Polka algorithm, the PESQ algorithm, the PSQ-LQ, PSQ wideband. So all ITU standards we support for voice quality testing. Auto measurement capabilities. It gives all detailed results, statistics, different rating criterias, remote access capabilities, delay measurements, jitter, clipping. These are all some of the different analysis metrics like noise, signal level, speech level, the PESQ, delay per utterance, and impairment factor. So basically, using these PESQ and Polka algorithms, you can perform voice quality testing. What it basically does is, it will compare the sent file once a call is established from side 1 to side 2, and interface can be anything. So it will compare the sent file with the recorded voice file, and based on that it will give you the PESQ scores. And if you are going for Polka, Polka is basically used for higher end networks like 3G, LTE and 4G, whereas PSQ is an older algorithm, P862.1 standard. It can be used for all the other networks like analog, 4-wire, any of these things. PSQ is used. Any questions on this?
Girish, can you please repeat the differences between Polka and P?
Yes. The Polka is basically used for higher end networks, where it's the latest algorithm. The Polka is the latest algorithm of ITU, which is used for higher end networks like 3G, 4G, and LTE, and it also supports HD audio, voice quality testing. Whereas PESQ is used for older. It's an older algorithm which can be used for 2-wire networks, 4-wire networks, as well as up 2G networks, and can be also used up to 3G. But Polka metrics are always preferred for WIPE networks.
The main differences between PESC and Polka, PESC is still a great algorithm, ITU P862, and it's used for PSTN, it's used for mobile networks, still works. Once you get into VoIP, and especially into wideband VoIP, where, you know, like VoLTE, voice over LTE is AMR wideband, PESC has some problems. It never really handled the wideband VoIP or even some of the narrowband VoIP networks very well. So they introduced Polka a few years ago. So that's a better algorithm for some of the VoIP networks or the wideband VoIP networks with voice over LTE. Now, you cannot run, unfortunately, you can't run PESC and Polka together at the same time on the same file, because there's differences in the files that the two algorithms use. Polka requires a very specific file that the ITU provides, male and female, whereas PESC uses pretty much any file except those files. They're not really formatted properly. So if you're going to run PESC and Polka, I do this all the time, to run PESC and Polka on the same call. You can send a file for PESC and then send the file for Polka, then analyze them separately. Our voice quality algorithm can do that. So you can set the voice quality algorithm up to say, no, analyze this one file for PESC and analyze this other file for Polka, and then produce the results. Hopefully that answered your question.
I'm basically asking, is Polka inappropriate for narrowband communications and measurements?
No, it's not inappropriate.
In other words, as the customer, you know, to get a complete, good picture of his, you know, to get good measurements across everything, does he need to get PESQ and Polka? Or if he just gets Polka, he's covered for all wideband as well as, you know, older standards?
Yes, Shelley, that's sort of a tricky question. It's a good question, but it's a tricky question. Polka can be used for all networks, but PESC has a lot better analysis feeds, you know, metrics, analytic metrics that come from the algorithm. For instance, with PESC, we get the signal level and the noise level and clipping and jitter and things like that, where Polka you don't get all those different metrics. The other thing we get with PESC is something that I love, is the PESC per utterance. So for each syllable stated, you can look at the PESC score. This will tell you if you have dropped voice within the call or dropped packets or what have you. Polka doesn't offer that because it's basically just one single sentence. So you do get some features in PESC that are not offered in Polka. That's why I still like to see the PESC. But the answer to your question, Shelley, is yeah, Polka can be used for both narrowband and wideband, you know, older networks and the newer networks.
But in that case, all of those other metrics that you mentioned, signal to noise, the levels, and all of those things, those would be missing if someone just had Polka. Is that correct?
They'll get the signal gain and the noise gain, but they won't get the other metrics. That's correct.
Thank you.
This is the auto measurement screen where this shows like we can perform voice quality testing both ways, manually as well as using auto measurement. When we do auto measurement, what we need to specify as in the screenshot is just provide the recorded file folder, and in the reference file you need to provide it what particular reference file or the send file we are using. So once you configure this, you can send different kinds of voice files as Rob said, but only for Polka you will need to use only two files, fem1 Polka and male1 Polka, whereas for PESQ you can use any files, but by predefined we give, with the installation we provide some files for different encodings, so user can use them. And once you configure these configurations for different files, you can just start the auto measurement. So whenever a particular recorded file comes into the specified directory, it will compare the sent file with the recorded file and give you the voice quality. These are the additional analytic metrics that we provide. It basically organizes the results into 5 categories like jitter, clipping, level, the PSQ utterance and delay per utterance. So jitter is basically it's nothing but the time offset between the reference and degraded utterances. It calculates the PSQ algorithm. It will calculate the levels for reference and degraded files. As you can see, the different metrics like speech activity, mean DC level, active speech level, mean noise level. So different analytic metrics. We also do get some analytic metrics for Polka like speech activity, speech level, SNR. So these are the additional analytic metrics which can be used to determine the voice quality measurements and the reason for its scores. Now we come to the data testing part as initially discussed in a brief manner. So you can see this is a block diagram of entire data testing. We have the data testing apps, GL's net test apps, which can be installed on any iOS app, on any Android app, and for Windows app currently we are going to come up in few times. So we can perform different kinds of data tests like FTP, DNS, HTTP. You can also perform data tests, PC based net test data test using whenever a PC is connected, Ethernet is connected to a PC, you can perform again these tests. Using our Vquad also we can perform tests over different networks like Wi-Fi, LTE, 3G, a router. Using Vquad can be anywhere in the world. It remotely controls the mobile devices through MDC and it starts the test. There is no need like Vquad has to be with the mobile devices. It can be anywhere and it will remotely control the mobile devices via MDC server, and you can perform different tests like TCP, HTTP, UDP, FTP, send and receive email. You can perform SMS for Android app, and again all these results will be sent to the central database and user can query the results, all the different data tests based on the phone ID, based on the location, different tests.
So let me just talk about this slide for a second, because this is a pretty cool solution that we have here. We have an app that sits on a phone. You put it on an iPhone, an iPad, Android. We're coming out with Windows. You know, put it on a tablet, whatever. And you run this app. And from the app, you can perform a test manually. So you can click on the app and say, I want to run an HTTP test. Basically, go to a website of your choosing and and confirm that it got to the website, if there was any errors getting to the website, and what the latency was. So it tells you how good the network is there. As well as giving you your signal strength and what network you're on. Are you on an LTE network or a Wi-Fi network or a 3G network, HSPA, whatever. So it gives you a lot of information for any test that you run. And you're running this manually, or you can actually run it in an automated fashion from the phone itself. I want to run this, what we call our auto test. Click it, I want to run it 12 times, or I want to run it continuously until I stop it, and it just runs the test, and you put the phone back in your pocket, and it's running tests. Or you make a phone call as it's running the tests, because it runs in the background, and it's always running. That's another key thing. It's always running. The app is in the background, and no matter what you're doing with the phone, our app is always running. If you turn the phone off and turn it back on, our app comes up. I mean, you can always close it, obviously, but our app otherwise will always be up. So you can run this app manually from the phone, and all the results get to the central database. The other thing you can do is you can run it from the Vquad. So in the Vquad, you can create a script to talk to a phone or multiple phones and tell the phones to run different types of tests. And here you can see the test in the bottom left cloud. TCP, UDP, VoIP, FTP, all these different tests you can run. You can run them one after the other, or just run one test continuously, whatever you want to do. And all the results get back to the database. So now you're walking around. You don't even set up the tests. You just have the phone in your pocket or the phone in your car, and somebody else is controlling the tests. We did this, for instance. We had a couple phones in a car that drove around Baltimore, Maryland. We were basically doing a test for all the bus routes. Now, the people that were driving the car for all the bus routes, they didn't touch the phone. All they were concentrating on is driving all the bus routes. We were running all the tests remotely from our location. There wasn't any equipment in the car, just the phone. That's all they needed was the phone. And we were running the test. I similarly put a phone in a car and drove to the beach or drove here or there, and there were just automatic tests running on the phone without me having to interfere. So it's a very good way to do these data tests, perform these tests on multiple devices, and get all the results back to the web viewer, and then we can plot them, as Girish will show you shortly, we can plot them on Google Maps, so you can see all the results, pass, fail, you can set up the results, there's a lot of filtering you can do, and you can see it graphically what happened during your test, okay?
Yeah, I think we have some questions from Zach.
Okay.
Basically, he wanted to know whether Google Maps is integrated. So I have told him that it is integrated, and we'll show a slide on that.
Yeah, actually, we use Google Maps in the web viewer. So we'll show you a slide because we're just using the GPS on the phone itself, and that's part of the result coming back to us.
Okay, do you have the measurement reports from the phone as well? So for the signal level, can we find out whether it's radio condition or network conditions?
Yeah, absolutely. Absolutely. We get all that information. We can plot it. We can plot just parts of the information. We can plot all the information, whatever you want to do, onto the Google Maps.
So can I replace the ASCOM and the Anite Nemo and drive test tools?
Well, the Nemo, that's a good question. We're actually going to replace the Nemo tool in one of our customers' sites, because the Nemo tool, the problem with the Nemo tool is that the data testing runs on their device. So it's not really a customer experience. You're running on their device. Now, let's say you bought a Nemo device that's 3G, and all of a sudden LTE comes out. What are you going to do? You got to get more devices from Nemo, and they love that. They're going to sell you more devices. Let's say you want to do voice and data at the same time. A very important test for these providers. We can do that because we can run the voice quality and in the same script run the data testing. And as far as I skipped over, as far as the 3G and the LTE, we don't care about the network because we put the app on a phone, any phone, okay? And whatever the phone's network is set up for, we run the test off of that network. So once we get to 5G, we're ready. It doesn't matter to us. Now Nemo gives you more information about cell information, network information. We give you a little bit, so we give you the cell sites and the neighboring cell sites and so forth. Nemo gives you a little bit more of that, but they're really not a customer experience type of test because you're using their device and so forth. We're more of a customer experience, and we can just, as I mentioned, you can just put the phone in your pocket or in your car or wherever, and without even knowing it, we're running tests, and we're not taking the phone away from you, meaning that while we're running the test, you still have full access to the phone. You can still make calls. You can still do whatever you want. You can go out to the internet while we're doing our tests. It doesn't matter. We're running our tests in the background.
Okay. How long will the battery hold, or do I have to put it on a charger?
That's a great question. That's a great question. So obviously, since we're using a lot of data, you're going to see the battery start dropping. Okay. If you're going to use this and run a lot of tests, we're normally seeing maybe 2 to 4 hours of battery life because it's a constant test. So you probably have to put it on a charger, or you can, if you only have a 2-hour test, it's no big deal. But we have on the app we have something called suspend mode, and we can remotely set the suspend mode from the Vquad. When we're in suspend mode, the phone is only going to talk to the central system once every 10 minutes to see if it wants to go into what we call our idle mode, which is ready to run a test. So in suspend mode, the battery degradation, is negligible. We don't really give any additional battery a drop when we're in suspend mode. So from the Vquad, we can tell the phone, go into idle mode. It may take up to 10 minutes because we have to wait for the phone to contact the server. It goes into idle mode, we run a test, and then we say, go back to suspend mode. So in that case, we're not really killing the battery that much. Okay.
So how mature is this system? Can we go and out of the socks, as we say?
Well, in terms of the maturity of the system, this has been around for several years already. It's being used widely in several providers, including AT&T, Verizon's using it. Some of the other countries are using it already. And in terms of the results, I mean, we've done many tests on the results. We reviewed them. They're all. I mean, it's a rather mature system. I guess that's all I can say about it.
Okay.
Hey, Rob. This is Chuck Reynolds. I have a quick question for you. is this being used more in an R&D effort, or is it doing it as more of a maintenance operational effort at AT&T and Verizon? Are they just doing it to check out new things from an interoperability standpoint before they deploy them, or are they actually just, weekly or monthly, running tests in an operational test mode? Or have they even addressed the modes that they're using at this point?
Okay. So let me answer that question. So in some of these networks, like AT&T and so forth, they're when they're deploying new software or deploying new antennas, or expanding their network, or as they're going to the next generation, they are using our equipment to test and to verify. And they're also using it in the labs. For instance, on this picture, you're seeing the femtocell. So they're testing the femtocell. They're making sure, they're isolating the femtocell, and they're making sure that the data testing is working through that. So, so they're using it for all sorts of reasons.
This is good for R&D, but if you go to the field, how would you distinguish between the radio access network and your core network and your other end where that is connected to the central data center or whatever? So where is the problem? On the web server that you are accessing, on the radio network between the phone and the app?
So we did a test in San Francisco. We were driving around the financial district. This was several years ago, and we were doing TCP tests and HTTP tests. And as we were driving down this one area, we kept hitting a hole where the network completely dropped off. So we kept driving back to that area, and we were hitting this hole. And our equipment was finding this problem. So when we got back to the office, we contacted the tower operator where that was. We found out which tower was being used, which cell site. We contacted them. They verified that there was a problem. The problem was resolved by moving the antenna slightly because there was some interference. And now the hole is gone. So I believe that's operational.
Yeah, but that's something that you find out that was in the operation part. But let's say I got poor results across many areas of the network. The question is whether it's radio issues or whether it's landline connectivity somewhere in the core network.
Why would it be landline? Because again, we're doing data testing here.
Yeah, you're doing a data testing, but you are coming from a radio access network to through a gateway, through the PDN, packet data network gateway. You are getting into the internet. So
well, remember what we're doing here. We are getting into the network the exact same way the customer would. So if the customer was standing there with their phone and they were trying to go to Google, and they're having a problem, that's exactly what we're doing as well with this in an automated fashion. So we're showing that the customer is having a problem right there.
But we can't pinpoint on what the problem is.
We can pinpoint that there's a problem, and we can pinpoint that there that there was packet loss, or there was a huge amount of latency, or there was no connectivity, or there was a drop of the network from LTE to HSPA, or the signal strength was very low. So we can pinpoint a lot of things right there as we run the test.
Okay.
So it really does give you a lot of information back as you're doing this test, whether it's some of our customers like to just run it continuously on a static location, and some customers are, a lot of customers are doing it via drive testing, or they're walking around. We have customers that want to use this app in a stadium environment, an environment with a lot of people, like a football game or something, and they'll run this app, these tests, and determine what the network or how the network is handling the load of all the people trying to get to the internet or what have you. And they may consider, well, maybe we have to put a sub-site here or something else.
Okay.
Yeah, this is a block diagram of how we perform data testing, automated data testing using Vquad. As Rob said earlier, we can control Vquad. Using Vquad, we can control mobile devices, and there is no need that mobile devices has to be near the Vquad. It can be anywhere. Via MDC, we can control these mobile apps, and you can perform complete automated data testing over different networks like 3G, 4G, LTE, and perform TCP, UDP, WIPE, FTP, different tests. And you can also perform email, SMS, and we perform some different network information and phone information tests like SIM info, UE info. So also it gives you the signal strength, RSSI, the battery level parameters, and all these results once again will be sent to the database web viewer, and you can query the results, as well as it will be plotted onto the Google Maps, where you'll get, based on the GPS coordinates, you can come to know the different network parameters quality at that particular point. So GL's mobile device controller application on Vquad and the supporting downloadable apps on smartphones can remotely perform the data test when the phone is within a voice call or outside a voice call. This is just like we discussed before. Like we can even when for using Vquad, when it is in the call is in connected state, we can perform data testing. So this is MDC. This is the MDC, where whenever you download an app or GL test app from iOS or any Android tablet or phone, you need to first register to this MDC server, and once you register to this server, only then you can perform the different net tests. And this will show you what is your phone ID, then the device name, then what is the status of your phone, which is very important, and whether the phone is in idle state or whether it is in suspended mode. Perform different tests. So basically this is the where Vquad also communicates, as well as the mobile devices communicate. Video testing currently we do not support, but
yeah, so we are working on video testing, and we should have that, I'm hoping, by later this year as part of the data testing. So that is coming.
These are some of the features of our net test apps running on different devices like the iPad and iPhone, and this is running on an Android phone. So as you can see, the apps on different devices that has been installed and how the GUI looks like. Different tests can perform. You'll get the status on the apps, like whether it is connected to the server or disconnected, then the status of the test, what test is running, and what is the progress of the test. These are all whenever you perform data testing on the mobile apps. And also you can see the maps plotted within the phone app. Also we do have support for Google Maps. This shows you the different net test results automated net test results performed from Vquad, and these are the logs as well as the status of the different tests, as you can see here. So some PC based net test is done, and on Android phone, the 880 iPhone. And what are the test results? You can see these test results on Vquad screen, as well as it will be sent directly to a central database and you can query it. So NetTest requires a GL data server at each target location, and the mobile device will require a GL deployed app. Now we come to our central database. As discussed, all the records from Vquad, VQT, and data testing, iPhone app, Android app, all the results can be sent to the central database via the data import. This data import, it receives all the necessary data from GL applications and saves the data in the database. Yeah, this is our web viewer which we are talking about. It's a web-based application that provides the method to display and access in real time the entire VQT network, including all individual Vquad probes as well as the central location. It will give you the real-time status of the Vquad VQT network, and also you can perform remote operations using this web viewer. It is a web-based application which you can run on any mobile, any tablet, anywhere with which you are connected to internet and query the results. These are the different records that have been shown, like for at what voice quality testing results for the Polka, the PSQ, R factors. This is some interesting graphical results over different voice quality tests for PESQ as well as Polka. So the x-axis indicates the time duration, whereas the y-axis indicates the Polka and PSQ scores in the ratings from 0 to 5. So 5 will always be the high, and for the 3 to 4, 4 to 5 is always an excellent, and 3 to 4 is good. So this gives you the different kinds of tests at different durations and what are the voice quality, what is the voice quality during this duration. So this helps you to just get an overview understanding of at what particular time the results are poor and good. This will give you the statistics of voice quality, like average PSQ, maximum of PSQ, minimum of PSQ. So different average scores, max and minimum scores, along with the graphical charts. As stated earlier, you can export all the results to PDF format. This is one of the examples how the results are formatted. This indicates, shows the side where you export the results to Excel. So we support Excel, PDF and text. And one more important feature is network status, where from WebViewer you can get the entire network status of Vquad as well as the script status and the device status. And from Vquad also you can...
This is a very important screen because what this is showing, it doesn't show it that well in this screenshot, but what it's showing is it's showing all the Vquads, all the nodes in your network at a glance. And it's showing who's up and running, who's not running, who has a test running, what tests are running, how they're connected. It shows you pretty much everything of the network. So if you have like one Vquad, 1 or 2 Vquads, it may not be as important. But if you have 50, 60, or 70 Vquads or more, then it's very important because it gives you a good glance of everything that's happening. And we can also plot this on Google Maps, so we can show in Google Maps at a glance where the Vquads are in the world, and which ones are running and which ones are not running. So a very important screen.
And similarly, this is another one of the important screen, remote operation. So from this web viewer itself, we can control different Vquad nodes. Like you can start a Vquad node, you can stop a Vquad node, you can load a script, you can start the script. So overall remote operations of a particular Vquad node can be performed using this option. It's one of the important features. Like as Rob said, when there are around 70, 80 Vquads connected, so this feature becomes important. Yeah, now this is where we are talking about the Google Maps. So in WebViewer, we have an option called Google Maps, so which will plot all the all the net test results or voice quality results or the call control event results into the Google Maps based on the locations and GPS coordinates. So for example, this particular graph shows the TCP pass and fail threshold. So, and from this you can come to know at what particular point and what particular area within test. This is a bus test as Rob described earlier, and plots of different GPS coordinates. So similarly, you can plot voice quality testing results, call control results, and data testing results.
So let me just go over this for a second. So there's actually two filters within the web viewer that were set to show this map here, this Google Maps. First, we filtered on the results. We said, okay, we want to show all the TCP results for a specific time period and a specific ID that we specified that for indexing the database. And then we put another filter in to show specifically TCP pass fail. And if you look in the icons on the map, some have a little V and some have a little S to differentiate between Verizon and Sprint networks. So, and this is all user configurable. You can do whatever you want. So this is basically TCP pass-fail tests within Baltimore. So this is actually the Baltimore Beltway. We're within Baltimore running all the different bus tests, and we can actually filter it even further to a specific time period where we're only going to get one line, and we can zoom out and all this other stuff, zoom in and see it a lot clearer. This is a TCP test. We can do any of the data tests or the voice quality test or path confirmations or call drops, call fails. All those things can be plotted on Google Maps. We're not limited to just the data tests. We can do anything. Very good.
Yeah. Yeah, this is another one of the important Google Maps feature where we plot all the different Vquad status, Vquad script status, then the phone status, and whether the test is in progress or not, and whether the VQT PSQ scores, VQT Polka scores, call connected state. So this particular graph indicates, as you can see on the right, the default legends. So these describes different pins, and based on that you can plot what actually is happening at that particular point.
So that's actually going around the Washington Beltway. The upper left hand, that's where our office is located. And we drove down to the Beltway, drove clockwise around the Beltway and then back to our office. And we had the Vquad running in the car. And we had a Vquad probe sitting in the car running, and all we weren't controlling the Vquad probe, but the Vquad probe was connected to the internet via a little, a tethered phone. So we had Wi-Fi on the probe, and it was connected to the internet that way. And we were just reviewing the results coming to the web viewer in real time as the car was driving around the Beltway.
Yeah, this also indicates the same slide where WashWeb belt test, where the different interfaces and different Vquad legend pins and the phone status. But it gives that.
Well, no, actually, what this is showing, this was actually taken just the other day, and this is showing another thing that you can show with the Google Maps. If you look in the upper left, you have an area where you can specify, I want to see the results for the Vquad nodes or the mobile devices. And on this graph, we're only showing the Vquad nodes and the mobile devices that are currently connected to the central system. And you can see a bunch of Vquad and mobile devices in the bottom right. That's where our office is in Maryland.
This screen gives us some of the fax results as stated before, like we support 2-wire as well as 4-wire fax for different fax standards. So this tells us the different fax tests we have performed, the fax state and the modem supported for that particular test, then the speed, the completed pages. So this gives you a complete picture of the fax results. And again, once again, you can query this to Excel as well as PDF. You can also filter based on timestamps. These are some data testing results which we are talking about. Like this is for particularly for TCP data test, wherein which we give the different parameters like TCP upload speed, the download speed, TCP average delay, the max delay, and the quality of service. So this gives you the different TCP test parameter results in a web viewer, and you can once again export these results. Similarly, we have for network phone parameters like phone info, SIM info, and UE info tests, which gives you the kind of network you are using. For example, in this slide, it gives network uses UMTS, then the RSSI, the battery levels, the phone software, phone info, the phone software version, as well as the app version. So these are different network parameters and the phone info parameters which can be viewed in the database. These are the features which are discussed till now. I mean, what are the different features supported from web viewer. You can also customize reports. You can create filters. User can create his own filters, user-defined filters, user-defined columns. Filters can be based on call IDs, phone ID, or any specific data test result, or any voice quality result.
As you can see, this is a complete solution, as Girish, as part of this whole presentation. It's voice, it's data, it's faxing, all different types of interfaces, and all the results going to a single central location for reporting. Everything in this solution can be set up as redundancy, so you can have multiple central systems. We're doing that for a couple customers, just in case one system goes down. We can have, we can set up backups. I think one of the questions earlier was, is this a proven solution? Is it a mature solution? And the answer is yes, because we have the facilities to set up if there's a problem, if a node goes down, if the network goes down, we have methods to back up the data, get the data at a later point, never lose any information. So that's all built into the entire solution.
Yeah, thanks, Rob. So I think this concludes our presentation. Thank you, everyone.